How do we find the value for A? And you got? All right, good. How about number 2? We have 2/5. How do we figure out how many 15ths that is? How do we figure that out? Ezra? So you say 3 boxes are equal to 2/5?
No, that's three, and it's kind of like, other than like, say, 5 rows and it's 3 down.
Mm-hmm.
So it's turning around and it's 3 going like this way, and you can't put 2 of those. And so it's 3.
All right.
Or we could have done 1 divided by 3, and we could have got 3, and then we times it by 2.
Okay, 15 divided by 5 is 3, and then 2 times 3 is 6. Anybody look straight across and see if you could shade in like 2 rows and be the same height? Okay, and there were 6 cubes, all right? Number 4, a number that is multiplied is called the factor. How many of you had true for that? True, yes, indeed that's true. Number 5, what was your product? Oh, I forgot number 3, subtract, what'd you get? What'd you get? Eduardo? Oh, did you add? Oh, let's subtract.
52 cents.
52 cents, 52 cents. How about number 5 now? What is your product?
$73.
Yes, $73.62. Number 6, when you add that together, how many hours and minutes do we have? Adam?
7 hours.
Yes, and number 7, if it fell 11 degrees, what would the temperature be?
39. 39. 41. 40.
Eduardo, turn around. There we go. There we go. And number 8, when you multiply any number by 0, the product is 0. And number 9. Yes. And number 10, what is our quotient, Cesar?
403.
Pardon?
403.
403? Not quite?
103.
What did you say?
103.
I was afraid you said that.
100.
There you go. 103. No and in there. 103. Quickly get that recorded. Are there any questions for me on that? All right, get it recorded. No talking. Let's get that recorded, please. Take a look at our answers to our assignment next then. we take a look at number 2, we went in 3 groups of 2,700s. 3 groups of 2,700s. That means that we should have shaded in 27 3 different times. So what you had shaded in? And that would give us, Jonathan? 243. How many squares did we have shaded in? We had 81 squares shaded in, and because it's out of 100, it would be 81 hundredths. 81 hundredths. Are you on 243? Okay. All right. Questions on that? For number 3, we need 2 groups of 45. There's 1 group. There's 2 groups of 4,500. Zach, what does that give us? We have 90 squares. It's out of 100, so it'd be 90 hundredths. Questions on that? Anybody? Okay. For number 4, you wanted 2 groups of 800ths. I'm going to use this one. Did yours look like that?
Yes.
Ava, what did it give us? What? 16. And they were hundredths, so it'd be 16 hundredths. Okay. For number 5, we want 2 groups of 67 hundredths. We've used up 2 of these 10 by 10s. What does that give us?
1 and 3,400.
1 and what?
3,400.
Okay. Questions on that one? Anybody? Okay. So number 6, 5 groups of 71 hundredths. You can use several of your 10 by 10 grids up, right? Okay. What'd you come up with?
3 and 5,500.
3 and 5,500? Okay.
I came up with 3 and 41.
3 and 41 hundredths. Should be 3 and 5,500. 3 and 5,500. When you do several of them like that, it's kind of easy to get off count. Okay. And number 7, you do 4 groups of 23 hundredths.
9,200.
92 hundredths. Okay. You've only needed 1 box for that. Okay. Questions on that? Okay. As we take a look at number 8, she walks a distance of 1,200 mile in 1 minute. She wants to do that for 9 minutes, so we need 9 groups of 1200s. 9 groups of 1200s. What did you end up with? You end up with what? And your label? Questions on that? You would have one whole 10 by 10 grid and then 8 boxes on the next one. Your question? I can't hear you. Okay. Number 9, it grows 45 hundredths of a meter in 1 year. We want to do that 3 times. So you filled up all of one grid and part of another one. What was your final answer? One what? Okay. Label? What was your label? Questions on that one? Okay. So number 1, as we take a look at it on the next page, what multiplication sentence does it represent? 1200 times how many?
2.
So we have 2 different sections times 1200. Anybody have anything else for that? 4 times 6 tenths or 600? Anybody have anything else?
I did 1, 0, and 2400.
You did 1 times 2400. Anybody have anything else? Okay, we take a look at the picture. We should have seen different shading going on. How many times did the colors change? Only once? Only twice? I see one here. I see it here. I see it here. And I see it here. How many times do I see it? 4. 4.
And then timing like 2.
No. Okay. You guys see that?
Yeah.
Okay. Okay. Number two. How many groups did we have going on there? How many groups did we have going on there? 5 groups? No. 3. How many groups did we have going on? 3. 3 groups of what? 3 groups of what? Lane? 3 groups of 5? No. 3 groups of 5 tenths. 3 groups of 5 tenths. If we have 3 groups of 5 tenths, and we were showing it in our grid, how would I show 5 tenths of that? 5 squares? Not 5 squares. 50 squares. Because 5 tenths would be a whole stick. That makes sense? 5 tenths is a whole stick. So I need 3 of those. I've got 2 of them there, so now I need a whole nother 10 by 10. And I need 5 more sticks, right? So what do I end up with? What's my total?
5.
Am I labeled?
Yeah.
Okay. Questions on that? When I look at number 3, it asks what operation would you do first? What's that?
7 plus 4.
Yeah, that is in parentheses. Number 4, Ella and 3 friends run in a relay race that's 14 miles long. Each person runs an equal part of the race. That's important to know. How many miles does each person run? What do we need to do to figure that out?
Divide.
What are we dividing by?
4.
Why 4, not 3?
Because it's Ella and 3.
Okay, so it's Ella and her 3 friends.
1 plus 3 is 4.
Okay. 4 goes into 14. How many times? What do I do with my remainder here? What do I do with my remainder?
Throw it out. We will
Throw it out. We don't need it. So everybody runs 3 miles? No? Mallory says no? What do you think, Mallory? You don't think we throw it out, though?
I think each person has 3.5 or 5. 0.5 of them are.
You don't think we throw it out, though?
I don't think you throw it out. I think you should split the 2 into 4 ways.
Okay, so you think we split the 2 4 ways?
Yes.
Okay, so you think we split the 2 4 ways?
That's what I was thinking.
Well, that's splitting the 2 4 ways. That's possible. Okay, that would work. It's a fraction. Can we use a fraction?
Yeah.
Okay.
And that's half.
Ezra? What? You want it as a decimal? Oh, not 4/10. No. And where did that come from? No, can't just make that a decimal. No, we can't just make it a decimal.
Okay, so we have to. So we get.
Is 2/4 a fraction?
Yes.
Is it possible
Yes.
to use a fraction and to have 2/4 of a mile?
Yep.
Okay, can we reduce that fraction?
Well, you have to 1/2.
Can we divide 2 and 4 by the same number?
Yeah.
What can we divide 2 and 4 by? What's a common factor of 2 and 4? And that gives us 1/2. Is 3.5 a possibility?
Yes.
So could they each run 3.5 miles? Is that possible? Okay. All right. Questions on that? Now, those of you who were talking about decimals, if I shaded in half of this, what would it be as a decimal?
Fraction. It would be 50.
50 hundredths or 5/10.
Yeah.
Would that work?
No.
3 and 5/10 of a mile? Sure. Okay. All right, number 5. What symbol do we put in there, and at what point do we know what symbol do we put in there?
Put a less than because the hundredth place is bigger.
Less than because the hundredth place is bigger. Do those two go together? Probably not. Less than and bigger?
Less than 8. Because the 8 is greater than the 8. 5 is closer to 5, the second number bigger than
So we would say the 1 in the hundredths place is less than the 8 in the hundredths place.
Yes.
That's why it's less than, yes. Number 6. How do we find the next number in the sequence? How do we find the next number in the sequence?
We just keep adding 1 0 to the end.
You keep adding 1 0 to the end. What's another way we could say it?
Multiply by 10.
Multiply by 10 each time. Yes, I prefer that other than we just keep adding a 0. Okay? We're multiplying by 10 each time. Question? Yes.
On number 4,
Yes.
exactly what you did on number 3, you had to do 5, you added a 0, and it was a hiking step. So what is that? 8 being 80
Where are you?
on number 4. On the front page.
Would 8 be an 80?
Yeah, because you used 5 tenths was a 15. You had 0 in it. So when the 8 being 80,
This?
yeah.
It could be 80.
Yeah, I got 1 and the full box.
But it's 80 hundredths. Right?
8.
80 tenths would look like this. Whoops. Here's 80 tenths. Because there's where,
It is 18.
okay. But here's 80 tenths. Because 80 and it landed in the tenths place. Here's what's there. That's 80 hundredths. Okay? And that's what's different. Okay?
Oh.
Does that help you? Okay. Thank you for asking. Ezra.
Right, that is there my collected on 6.
On 6.
Yeah. On the back side.
Go ahead quickly.
By looking at the 0 and realizing if you times it by 10.
You multiply it by 10. Yep. If you use the word multiply, I like it a whole lot better. Thank you. Any other questions? All right. Moving on then. Today we're going to take a look at using the distributive property. Using the distributive property, multiplying with decimals. So let's please turn the page. We're going to take a look at 5 times 2 and 5 tenths. 5 times 2 and 5 tenths. Now, we worked with the distributive property quite a bit this year, just looking at how we can separate out our numbers, right? Yes, please say you remember that? Yes, yes, yes. Okay.
No.
So, first off, we can estimate the product. One way to estimate would be to round to the nearest whole number, and if we were taking a look at 2 and 5 tenths and we're rounding it to the nearest whole number, 2 and 5 tenths would round to 3. Thank you very much. And we round to 3. So 5 times 3 would be 15. So we know that our final answer should be somewhere close to 15, right? And if I'm writing, you're writing, of course. Okay? So we know that our final answer should be somewhere close to 15, all right? As opposed to like 1 and 5 tenths or 1500. And that's what's going to be important here is it'll help you with the placement of the decimal point. Okay? Does that make sense? All right? So our next step is looking at the distributive property. We're taking a look at how we can separate out 2 and 5 tenths. How we can separate out 2 and 5 tenths. 2 and 5 tenths can be separated out by separating the whole number and the decimal into 2 plus 5 tenths. Any questions on that separation? Anybody? Ezra. All we're doing is separating that 2 and that 5/10. That's all we're doing. Okay? Remember how when we talked about like 42 times 7, we said that could be 40 plus 2 multiplied by 7. Do you guys remember that?
Oh!
Light bulb about blinded to me there, folks. Oh. All right? Okay? That's all we're doing here. 5 times 2 and 5/10. All we did was separate out that 2 and 5/10 into 2 plus 5/10. That's all we've done so far. Okay? That's it. That's it. So now, remember how then we did 7 times 40 plus 7 times 2? Remember that?
Yes.
Okay? That's all we're going to do here then is 5 times 2 plus 5 times 5/10. That's all we're doing. Yes? Okay? You can relate that to this? Yes? Okay? Well, 5 times 2 is 10. 5 groups of 5/10. Well, let's think about our grid over here. 5 groups of 5/10. This is 5/10, folks. 5/10. 1, 2, 3, 4, 5. That's one of them. 1, 2, 3, 4, 5. That's 2 of them. 1, 2, 3, 4, 5. That's 3 of them. 1, 2, 3, 4, 5. That's 4 of them, right? I want you to come up here, please. We only have 4 of them so far, and we need how many of them? 5. We need 5 of them, so we need one more set of 5/10. There's 5 of them. What do we have here?
We have 5 of 5/10.
We have 5 groups of 5/10. What's our total now?
2 and 5/10.
2 and 5/10.
Oh!
We drew a picture, right? Yes, no? 2 whole amounts. 1, 2. This is 50 hundredths or 5/10. We don't need that 0, right? Yes? Does that make sense? So now we had 10 plus 2 and 5/10. So that 10 plus 2 and 5/10, we need to remember that we have to line up our decimal points. Gives us 12 and 5/10. Now, is that anywhere close to 15? Okay, well, let's take a look at that and see what we mean by close, okay? If I put 15 here, it'd be like 15 and 0/10, right? Okay. Is it close?
Yes.
Yes, because otherwise we would be looking at this number being like 125 or 1 and 25 hundredths or something like that. Does that make sense? And are either of those numbers close to 15? No. Okay? Eduardo.
I didn't get that.
2 times 5 right here. Okay? So when we're talking close now, we're talking about looking at, is the decimal point in the right place? So if I have 15 as my estimate, is 12 and 5/10 close? Yes, because if I had that decimal point anywhere else, it wouldn't have been close. Does that make sense? Questions on that? Okay. Take a look over here at the other way we can look at it. Yes. If you have 12 and 5/10 and you have 15, are those two numbers close? Yes, that's what I mean. Okay? All right? Okay. Let's take a look at this over here. If we put 2 and 5/10 and we want 5 groups of that, well, what's 5 times 5?
35.
Okay? We can show our partial product by looking at there's step 2 down here, the 2 and 5/10. That make sense? Remember how we drew this picture over here? It gave us the 2 and 5/10. So 5 groups of 5/10 gave us the 2 and 5/10. So our partial product here became 5 times 5/10. By drawing that picture, remember the picture we drew over there? Okay. Our next piece then would be to multiply that 5 by 2, and that gives us our 10. So this is 5 times the 5/10. This is 5 times 2, which is 10. And then we can add them together, giving us our 12 and 5/10. So that goes back to when we did like 15 times 4. 5 times 4 is 20. 4 times 10 is 40. Remember that?
Yeah.
We added them together and we got 60. Okay? So that goes back matching up with that. Eduardo? Does that help you? 10 and 0/10? 5 times 5/10 is 2 and 5/10. Remember the picture we had over here gave us 2 and 5/10? 2 whole boxes plus half of another one. Okay? So that's a second way we can do it. Thank you. A third option is to eliminate the decimal point altogether and do our multiplication. Okay? By doing that, 1 and 3,500 times 100 gives us 135, right? We can do our multiplication, which would give us 1,080, right? But now we have to go back and get that decimal point back in there. So we have to undo multiplying by 100. The opposite of multiplying by 100 would be multiplying by 100, right? Yes? If I go 2 steps this way, the opposite is to go 2 steps this way, right? So these would be my opposites, right? Does that make sense? These are my opposites, if I'm going to undo it, right? Those are my opposites. So if I'm going to have to come back 2 steps to the left, and I have this, then there's where my final decimal point belongs. So my final answer would be 10 and 80 hundredths. Okay? So there are 3 ways to look at it right there. All right? So, if we go down here to number 1, if we do an estimate, 6 and 81 hundredths would be rounded to what? Seven. And 7 times 7 is what? 49. So where would we place the decimal point?
Between 4 and 9.
Between what?
4 and 9.
We don't have a 9 here.
Oh.
Ooh. Between the 7 and the 6 will become 47 and 67 hundredths. Does that make sense? Okay. When I look here at number 2, 3 and 7/10 would round to what? 4. 4 times 2 equals what?
8.
8. Where would my decimal point be in my final answer? Is 7 and 4/10 close to 8? Okay. Question?
Why do we have to do the 400 with 8?
All we're doing is placing the decimal point in the final answer. So we are rounding that number to come up with an estimate to know where to put the decimal point. Okay? Eduardo.
How do you know this?
If this estimate is an 8, and I have a 7 and a 4, if I put the decimal point here, is 74 close to 8? If I put the decimal point here, is 7 and 4/10 close to 8?
Yes.
If I put the decimal point here, is 74 hundredths close to 8?
No.
No. Then this is where I want my decimal point. Okay? Take a look at this one. What would I round 19 and 34 hundredths to? 20. 20 times 5 equals 100. I have a 9670. Where is my decimal point going to be if I want my number to be close to 100? Jonathan? There we go. Yes? Is 19 an easy number for you to multiply by 5? Is 20?
Yes.
What?
Is the decimal point at the top of the multiplication or is this a problem?
You cannot rely on that. It won't work that way all the time. Okay? It's a good observation for now, but it won't work that way all the time. Okay? That's what we're doing on the other methods. The reason that doesn't work all the time. All right? Questions so far? All right. Turn to page 249. Have your pencils ready. Number 2, put these numbers down for the answer. 5, 8, 8. Number 2, put these answers or these numbers down for the answer. 5, 8, 8. Number 3, put these numbers down. 6, 5, 1, 0. Number 4, 7, 5, 7, 8. Pencils should be working. Number 4, 7, 5, 7, 8. Number 5, 9, 8, 3, 5. Number 6, 1, 1, 9, 1, 0. 1, 1, 9, 1, 0. We're on number 6, Eduardo. I'm telling you what the answer is without the decimal point in it. You can write the digits down. I'm going slowly. I'm saying the number. I'm pretty sure you can follow along. I'm watching as people are writing things down. Number 7, 3, 7, 2. Number 8, 2, 3, 7. Number 9, 2, 1, 4, 4, 5. I'm going to say number 9 again. There are lots of digits in there. 2, 1, 4, 4, 5. Number 10, 2, 0, 8. Now, here's going to be your job. You come up with an estimate by rounding and decide where the decimal point needs to go. That's all you have to do tonight. Okay? Just those. That's it. Eli. 6, 5, 1, 0. Tyler. 9, 8, 3, 5. Okay. Estimate. Place a decimal point. I must see what numbers you used for your estimate. Okay? Just like what I did up here with you on these last few. Does that make sense? Does that make sense? Okay? Questions? Okay, get started. Any questions from home? Winnie and Caleb and Emily. I will see you this afternoon in social studies. Yes? Okay. So I know and do math, okay? That makes sense? All we did yesterday was work on projects. We didn't do anything new. Okay?